Please don't forget to like, subscribe, and comment. Thank you so much.
Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +2348085095144 to learn more and get started today.
So completing of square, if you have an example x squared plus 6x minus whatever. Or can I, so that it's something that is factorizable and then you can compare. So I will use x squared minus 6x. That will be something that is factorizable, and then when you're done, you can easily compare. Minus 6x plus 9. You have to rewrite the expression in the form of x plus k raised to power 2, then plus whatever constant, plus or minus c. But I will use a different word so that it doesn't look like the c for intercept. You know? So, plus maybe b. So I'll just call this one a. Oh, I don't want to be using symbols that are standard symbols we use in factorization. But let me explain. You know the general formula for quadratic function, ax squared plus bx plus c. I'm just trying to avoid those a and b and c, so they don't look like that's what I'm talking about. So f of x equal to this, or y. That's the general formula of a quadratic function, ax squared plus bx plus c. You know that already?
Yes.
All right, so you have to rewrite this in this form. What do you do? First of all, just find half of the coefficient
Half of b and square it.
Yeah, and square it and add to that. So, like you already know, half, wow, this is big, so let me reduce the stuff. So half of b is minus 6 over 3, isn't it? Which is, oh, sorry, minus 6 over 2. I mean half of b. That's divided by 2. Minus 6 over 2, which is minus 3.
Minus 3.
You know b is 3. So a is 1, b is minus 6, and c is 3. 9. 9 is 9. Comparing with this. Okay, half of b is minus 6. Minus 3. So what you simply do is start a bracket, write x minus that half of b, or plus that half of b, plus that half of b. Let me put it in the general form it is, plus half of b. That's b over 2, close the bracket, squared, then minus that b over 2 all squared, before you continue the rest, plus c. That's how we should always be.
Okay.
Open the bracket, x plus b over 2 all squared minus that b over 2 squared, then plus c. Can we apply it there? So this will be equal to just substitution. Let's substitute.
X, okay, bracket x plus, no, x minus 3.
Okay, because b over 2 is minus 6, so plus b over 2 would now be minus 3. Close the bracket. All squared.
3.
Then minus.
Minus 3 squared. plus 9.
That's minus 3 squared. Then plus 9. Why am I giving something that that doesn't have a C? Anyway, no problem. It's fine. So that would be x minus 3 all squared minus 9 plus 9. In this case, okay, incidentally, the one I gave is the one that has this equal to 0, right? So this is x minus 3 all squared plus 0. You know? That's the way it is. So that's just a simple rule. When you want to complete square. So can we do this to drive it home?
Okay, hold on. Let me write this down first.
Okay, let me scroll it up a bit.
Okay.
So of course, in this case, whenever you do this, you will need to compare it with all of this. So K is what here? Comparing with this. K is what?
Okay. K is minus 3
K is minus 3.
and Q is 9.
Q is what? No, Q is what?
K is 9 now. Q is 9.
No, you are comparing with this.
Right.
You are comparing with this.
I
Yeah,
know.
Q is minus 9 plus
Q is
9 is
9.
0. Minus 9 plus 9 is 0.
Q is 0. Sorry.
Q is 0. If you were to sketch this, you know, because one of the uses of completing of square is for sketching graphs. How will it look?
How do you look here?
I was talking about how you can apply this to plot the graph. That's one good thing about completing of square, because the Q gives you the maximum or minimum value, you know that, where the turning point.
Wait, so
Yes.
is this completing this square thing? Is it like vertex form of a graph?
Yes, it gives you the vertex. It just gives you the vertex. You use that to get the vertex of the graph. In fact, with that, because Q is the vertex, the value of the y value of the vertex. And to get the x value of the vertex, okay, maybe I should write that before I even start plotting. The y value of the vertex, let's say all of those things first of all, which is the turning point. This one is not so good. The y value or coordinates of the vertex, which is a turning point, which could be minimum or maximum value, depending on whether the graph forms a U or an N, you know all of that. It's simply equal to Q. The y value, coordinate of the vertex, minimum or maximum value is simply Q. Y the x value, and the x value, or x, to get the x value, what you do is, you do whatever is inside the bracket equal to 0 and solve it. So x plus k equal to 0, and then you solve it. In this case, that will be what is inside the bracket, in the one we're looking at.
Okay, so x plus q is always equal to 0.
Yes, to solve, to get the x coordinate of the vertex. So in this case, what should we express equal to 0? Whatever is inside the bracket equal to 0 to help us solve, to get the x coordinate of the vertex. This is what is inside the bracket now, isn't it?
Mm-hmm.
So can we do that? That will be x minus 3 equals 0, isn't it? Just express whatever is inside the bracket equals 0. And that gives x equal to what?
Plus 3.
Plus 3. And that's how we can easily tell the vertex, the coordinate of the entire coordinate of the vertex will be in this question we solve, the coordinate of the vertex is what? Mm-hmm.
So
Remember, what's even q here?
0.
0. So the coordinate of the vertex is what?
3, 0.
3, 0. In fact, the graph will form, we cut the x-axis at
Okay.
one point. Talking about discriminant.
Yes.
This number 2, what should you do first? Let me write it here.
Divide 2 by 3.
Divide all through by 3. That's correct. All right. So I can remove it from here. So let's go. Divide all through by 3. So when we divide all through by 3, we're going to have that 3. Don't throw it away. Oh. Did you hear me? You still will not throw it away. Yes. Very good. Very, very good. You cannot throw it away. But if it was equal to 0, if it was equal to 0, you can afford to throw it away. You can divide all through by 3. And it becomes x squared minus 3x plus 50 over 3 equal to 0. So you can throw it away. But it's not an equation. It's an expression. So you can't throw the 3 away. You will divide all through by 3, but it will still be there. Did you hear me? All right. So I was trying to caution you about something. Yes, you divide through by 3, but you're not going to throw it away. We have 3x squared minus 9x plus 50. If you are to complete the square, you won't throw the 3 away even after dividing. But that is different from if it was an equation. If you had this equal to 0, did you hear me? Sorry, if that was equal to 0, that is now an equation. For an equation, whatever you do to the left-hand side, if you do it on the right-hand side, it's still valid, it's still logical. This one we can divide through by 3. I have to emphasize this. So I can say divide through by 3. The reason is it is still valid. Okay. It is still valid. For instance, if you divide, let me just use this because these are just algebraic manipulations. If you have 8 equal to 16 over 2, is that correct? Is 8 equal to 16 over 2? Are you listening to me? Is 8 equal to 16 over 2? You're not sure? You think I'm setting you up for something? It's just a very clear thing. 8 equals to 16 over 2 now, isn't it? Are you still here?
I'm still here.
Okay. Yes, 8 equals to 16 over 2. Multiply both sides by 2. Will it still be valid? That's the point. The thing is about validity. Multiply both sides by 2. Will it still be valid? Multiply the left hand side by 2. What do you get? 16. Multiply the right hand side by 2. What do you get? 16. Is it not valid?
15, yes.
Divide both sides by 4. Will it still be valid?
No.
No. Whatever. Let's see. Divide both sides by 4. If you divide both sides by 4, divide 8 by 4, what do you get? That's 2. Divide 16 over 2 by 4, what do you get? That's also 2. So it's still valid. I said all of this to say this. For an equation, whatever you do on the left-hand side, if you do it on the right-hand side, it will still be valid. That one is equal to the other will still be valid. Yes, it's still valid, because if you divide 8 by 4, you get 2. If you divide 16 over 2 by 4, you get 2. You know, that is for an equation. That is for an equation. But for an expression, if you are simplifying and you are dividing, make sure that thing stays outside. Okay. Compare it with. All right, let's even get the answer to this one. Divide 2 by 3, that would have been x squared minus 9x, sorry, 3x. I'm dividing all 2 by 3. 3x plus 50 over 3 equals 0. And so it's still valid, because I divided both sides of the equation by 3. But compare with this. Compare with this. Compare with this. 3x squared minus 9x plus 50. This is not an equation. It's just an expression. Did you hear me? Okay, compare with 3x squared minus 9x plus 50. It's an expression. This is an expression. This is an expression. If you want to simplify it, if you want to simplify it by dividing 2 by 3, you have to retain the 3 outside the bracket. So if I say divide or simplify by dividing, simplify, you know, I'm coming. Simplify by dividing through by 3, that it will now become x squared minus 3x plus 50 over 3. But the 3 will stay outside the bracket because it's a simplification. All right, I think I will have to explain this very well. So this, is it an equation or an expression? What I'm directing my arrow to. Is it an equation or an expression? Anything that does not have equal to something is an expression. This is an expression. Am I still here with you? This is an expression. So you can only simplify it. You can't just divide it through by something and throw away the thing. No, you cannot.
Why?
Because it's an expression. If you do that, it won't be logic valid again. I can
All right.
I can
Okay,
still,
so does that mean that when we get the answer that we should multiply by 3?
yes,
Oh, I know.
this one is an equation. This is an equation. This is an equation. So you can divide by 3 and don't bother about it, because when you divide all through by 3 for an equation, it is still valid. And I showed you the validity with this example. You have 8 equal to 16 over 2. If you multiply by both sides by 2, you got 16, and for the left hand side and 16 for the right hand side. So it's still valid. 16 equal to 16. So long as it is true that one side is equal to the other side, it is valid. It did not contradict yourself. And when we also tried multiplying by 4, we discovered that we multiplied by 2. First of all, we got 16 equal to 16. Then we divided by 4, we got 2 equal to 2, so it's still valid. What is on the left hand side is what is on the right hand side, because it is an equation. And we did not contradict anything. So, but for an expression, if you are dividing through by something, you need to return it outside the bracket, because you are just factorizing. Otherwise, it will not be correct again. It's not the same value. All right. I said all of that to emphasize that when you are completing square for this, you can't throw that away easily like that. So, can we do the work now? All right. So we can. Right. Remember where we are coming from. The question is this. Can you read it?
Yes.
Read it out, please.
3x squared minus 9x plus 50.
We have to complete the square. All right.
Again,
So,
charger.
and I said to simplify it, divide through by 3. You even suggested it. So we've done that. I just wanted to remind you that you don't throw away the 3, because it's not an equation. So after that, what do you do next?
After dividing 3 by 3, you do the same thing now. That
We'll complete. Beautiful. Let's complete the square for the one inside the bracket. So beautiful. Let's just go ahead and do that. Just leave these 3 and do the work. Let me put it like this, so that we can complete the square for the one inside the bracket.
Okay.
So shall we? Don't forget the rule. Can remind you. Open the bracket x. Open the bracket x plus b over 2 squared minus b over 2 squared plus c. Let's go. So put it in here. What's a? What's b? First of all, it's b that is important.
Minus 3.
B is equal to minus 3. And what's c?
50 over 3.
50 over 3. Okay, so let's just put in there. So let's go. We have 3, a big 3, and then we complete the square of the one inside the bracket. So let's go. Shall we? So open a bracket.
X minus x plus 3 over 3.
No, it can't be x plus 3 over 2. You told me b is minus 3. So b over 2 is...
I know. Okay, yeah, sorry. Yeah, x.
X minus 3 over 2.
3 over 2.
Close the bracket. Squared. Hold on.
Plus.
Sorry, hold on. Let me be sure I copy the correct thing. Oh yes, I divided 2 by 3. This 9x is 3. Okay, that's correct. I copied the right thing. X minus 3 over 2 squared. Go ahead.
Minus
minus, open a bracket, minus 3
Oh,
over minus 3 over 2
okay, yes,
squared, which
minus
we
3
won't really,
over
it won't, because once you square it, it doesn't matter whether it was minus or plus, then
2.
plus 50 over 3.
3.
Then we have our big bracket. Remember this 3 outside is still locked in there. We didn't throw it away. So let's go. This is equal to 1. I mean, we can even do it here. 3, open a big bracket,
X minus 3 squared.
x minus 3 over 2 squared.
Yes.
Can you just simplify this one?
Okay.
Okay, let me write it. That's 9 over 4 plus 50 over 3. Please work in fractions. It's neater to work in fractions. You have to learn to.
So that will be 227 over 12.
All right, so this becomes 3 in big bracket out, then the small bracket. Yeah, you're getting it. X minus 3 over 2 all squared minus 9 over 4 plus 50 over 3. What did he say you got? Is that plus?
I got minus 227 over 12.
How can it be minus? 50 over 3, 50 over 3 is bigger than 9 over 4.
Oh, eh?
I'm asking you to do only
Okay,
this
hold
place.
on.
Only this place. Minus 9 over 4 plus 50 over 3. SCM is
173 over 12.
plus or minus?
Plus.
Plus, okay. All right. So let me write this again. Okay, so sorry, let's discover very well. That's plus 173 over 12, you said? Interesting. You can leave this as an answer, or you can make it neater. We can make it neater, because sometimes they write the answer in a way that if you didn't know, you wouldn't think that this is actually right. At this point, you can remove the bracket. That's that big. You know, this 3 is multiplying everything inside the bracket.
Yes.
In fact, the 3 will multiply, open the bracket, x minus 3 over 2 all squared, and also it will multiply 3, open the bracket, 173 over 12. Trust me, they love something like this because they want to make things, gives you options that you wouldn't know it is exactly what you got. Did you understand what I just did now? It's just distributive multiplication. I just distributed the 3 to this and to this. Is that not?
Yeah.
Yes, I just distributed the 3. 3 multiplied by this first bracket and 3 multiplied by 173 over 2. Is that not what I just did?
Yeah.
So we are online. So finally, simplify this fully. What would this actually be? Let me now write it in red. Give me the answer. Simplify this fully. This will be 3, open a bracket, x minus 3 over 2 all squared plus, simplify this one. 3 goes here 1, 3 goes here 12, 4. So that will be what?
Oh, I don't know.
173 over 4.
Okay, yeah, 173 over 4. Oh, I forgot that.
Can I just tell you that if you did not do this, you will not identify the real coordinate of the vertex. So what's the coordinate of the vertex?
Minus 3 over 2.
Coordinate.
Comma
Did you say
1,
minus?
3 over
Did you say
2.
minus?
Agree now.
It's not minus 3 over 2 because you are expressing the one inside the bracket equal to 0. X minus 3 equal to 0 will give you x equal to what? Don't forget that you always
X equal to 3 over 2.
x equal to 3 over 2. So the coordinate of the vectors will be 3 over 2 for x. Then comma, what about y? 173 over 4. Is it not?
Yes.
So that's a trick. At least if you have learned this, I'm happy. You know, can I just tell you that this was not the coordinate of the vertex? You see this one I circled here? Please look at it again. You see this 173 over 12? It's not the y coordinate of the vertex. 173 over 12 is not the y coordinate of the vertex. Because we haven't simplified it further. I'm happy that you brought this up. I'm telling you, I've seen this. You need to simplify further, distribute the 3. And then, of course, you will see that 3, open a bracket, all that will simplify.
The voice is cracking.
I hope you can hear me now. That's it. That's what you should take note of. Don't fall for the trick that 173 over 12 is the y coordinate of the vertex. It is not the y coordinates of the vertex. You have to.
What is it?
You have to. We distributed the 3 outside now.
Oh yes.
3 times that
True.
and 3 times that. Before we could get the actual y coordinate of the vertex. So each of those things multiply by 3, multiply by 3. Did you get a trick?
Yes.
Because if you didn't do that, you wouldn't know which is which. So the y coordinate of the vertex is 173 over 4. The x coordinate is 3 over 2. All right. You can attempt these ones. Are you listening to me?
Yes.
See these ones. Let me zoom it in very well so that you can see. A to E, A to H. Look, I can just give you a clue here. This one. What do? There's no big deal. It's just the same principle. Read it out, the G, which you can practice. Read out that G.
24 plus 12x minus 2x squared.
Beautiful. So,
wow.
you know, it's not a big deal. Why will you rewrite it? So that, just a hint.
Minus 2x squared plus 12x plus 24.
First of all, it will become minus 2x squared plus 12x plus 24. Minus 2x squared plus 12x plus 24. So what do? You bring out the by minus 2. By what?
Is it by 2 or by minus 2?
By minus 2, of course. Minus 2 comes out. You open your big bracket, and then you continue with the rest. So minus 2 comes out. What would this be? X squared, right?
Yes.
This becomes what? Plus 12x becomes what now?
6x.
Did you say plus? You just open the bracket with minus.
Minus 6x.
You should be careful. So minus 6x, then minus 12. Am I right? And close your big bracket and do the rest. You can finish it off from here. Just complete the square for the one inside the bracket, isn't it? Let me just get it to a point and then you finish off the rest. It's your work.
So I should do this.
You can, yes, please. You just do it and give me the answer. First of all, let's get it to a point together.
bracket. Okay, minus 2, big bracket and small bracket, x squared
minus 2,
minus 3.
big bracket. Okay, let me just zoom out very well so that I can write easily. All right. Set small bracket, then x minus b is minus 6, so it will be minus 3, isn't it?
Yes.
Squared, then minus. We can just do it without wasting time. Minus 3 over minus 3 squared is 9, then minus 12.
Oh, minus 12 here.
So it's easy. Minus 12 before you close your big bracket. So what does it become? Minus 9 minus 12 gives what?
Minus 21.
Minus 21, okay. So see how it is. So we simply have, open our bracket again in green, x minus 3 all squared minus 21 before we introduce the big bracket. You know? So what do we do at this point? Distribute the minus 2.
The minus 2.
So now will become, the final answer will now be what? Minus 2, open the bracket, x minus 3 all squared, then minus what? What is minus 21 times 2? As minus
42.
No, minus 21 times minus 2. You see why you should be careful. I told you, as plus 42. Minus 2 times minus 21.
That's true.
Yeah. So what's the x coordinate of the vertex? What's the coordinate of the vertex? In fact, I'm proud of you.
Plus 6, 42.
Plus what? Not plus 6. So
Six.
no. It's just what is inside the bracket. It doesn't matter the minus 2.
Okay.
Yes, thank God this came up. It does not matter what is outside the bracket. It's what is inside the bracket.
Oh, okay. Okay, so negative 3.
No, remember it's minus. You do x minus 3 equal to 0. Don't forget.
Oh, yes. Okay, 3 comma 42.
So the coordinate of the vertex is just 3 comma 42. 3 comma 42. Because when you say x minus 3 equal to 0, you get x equal to 3. And it's just the positive 42. You see that? By the way, when you are sketching this, you see that it will form a U or an N. A sketch will form a U or an N because A is equal to minus 2. Remember, A is minus 2, which is less than, A is less than 0. So it will form an N, isn't it? The graph will form an N.
Yes.
It will form an N. It will go like this. All right. And then, of course, you know the vertex, coordinate of the vertex is 3, comma 42. And you form an N. You know the intercept is plus 24. So it will pass through plus 24 without even doing so much. You know, that's the intercept, plus 24. So it will pass through plus 24 like this. I don't know what will be the root. Assuming it's like this, where here is 3 comma 42. And the intercept is 24. 0, comma 24. Coordinate of the intercept. Okay. By the way, if we solve the equation x squared minus 6x x squared minus 6x equals 0, we'll find that the solution will be, anyway, just a simple minus b plus or minus the square root of b squared minus 4ac all over 2a. That's going to give us 6 plus or minus square root of 36 minus 48 all over 2. That will give us, that's just a very quick one. Let's just finish it up here. That will be 6 plus or minus 9.2 over 2. That will give us the two values of x as minus 1.6 and 7.6 thereabouts. Okay, that's approximately. So the two roots will be shown here, and here, where this place is. This place is minus 1.6 and this place is 7.6. If we have to sketch it fully, remember here is the intercept, which is 0, 24, 0, 24, while here is the vertex of the turning point, which is 3, 42. So the full sketch will look like this. The x values for the roots, which is this, minus 1.6, and that's x1 and x2 here, the two roots of the turning point. So the full sketch will include the roots where the curve will pass the x-axis, the intercept 0, 24. Remember how we call the intercept from the original equation. This the value of c from the original equation, and then the turning point, which we got earlier, which is the vertex where x is equal to 3 and y equal to 42. All right, there's an alternative method we can use to solve completing of square or complete the square of for quadratic expressions. Like let's use this number, this a, 2x squared plus 4x minus 8. Let's use that for an example, or as an example. 2x squared minus plus 4x minus 8 or let's even use this one that we already have the answer so that we can compare the answers. 24 plus 12x minus 2x squared. 24 plus 12x, 24 plus 12x minus 2x squared. So we have to complete the square. Now this is the alternative method. The alternative method. So, by the way, we are required to put the equation in this form. A, open a bracket, x plus q squared plus k. That's what we are also required to put here. A, open a bracket, x plus q all squared plus k. All right. Now let's do this so that we can compare it with the answer we already got earlier. All right. What we do is simplify the left-hand side. Actually, the right-hand side. You know, in this question, we have both the left-hand side and the right-hand side. And we compare. Let's simplify the right-hand side first of all. Simplify the right-hand side, we're going to have A, open a bracket, actually big bracket, x plus q times x plus q. Before we close a big bracket, and then plus q, plus k rather. All this squared means multiplying it by itself twice. That's a plus x plus q times x plus q. That's what it means. Okay, so we have a, the big bracket. We multiply this by distributive multiplication. X times x gives us x squared plus, in fact, that would be 2sq or 2qx. Let me just write it properly. 2qx plus q squared, close the bracket, before plus k, and then we simplify fully. That's going to give us a x squared, opening the bracket now, plus 2aqx plus aq squared plus k. Alright, that's what we have. So what we just need to do is compare the left-hand side with the right-hand side. Remember, the left-hand side is this 24 plus 12x minus 2x squared, and it has to be this, it must be this. So comparing left-hand side with right-hand side, that's another way that can be done. So comparing left-hand side with right-hand side, we compare each term by term. First of all, the term in x squared. For the term in x squared, on the left-hand side, what we have there is minus 2. While on the right-hand side, what we have there is a. So that simply means a is equal to minus 2, which implies that a is equal to minus 2. We have it. So that's the term in x squared. We have minus 2 on the left and then a on the right. So for the term in x, on the left we have 12, on the right we have 2aq, and we already got a to be equal to minus 2. This means 2 bracket minus 2q, or minus 4q, and this means q will be equal to, q is equal to 12 over minus 4, or q is equal to minus 3. Just solving the question. All right, so we have q. Then we compare the constant. The constant, we started with the term in x squared. We've done that. You know, term in x, we've done that. Now we look for the constant. The constants are the ones that don't have x. So for constant, on the left-hand side, the constant is, let me write it down here. For the constant, on the left-hand side, the constant is 24. So we have 24 equal to, For the right hand side, the constants are the ones that don't have x. That's aq squared plus k. aq squared plus k. Or we already have a and q. A is minus 2, q is minus 3, all squared, then plus k, which gives us 9 times minus 2 is minus 18 plus k. So 24 is equal to minus 18 plus k. That gives us k equal to 24 plus 18. And 24 plus 18 is 42. Yes, 42. So k is equal to 42. So we have it. We have all the a, q, and that. So I'll write them out. A, therefore, a is equal to minus 2. Q equal to minus 3. And k equal to 42. So when we have that, we can just substitute. Remember, what we are required to do is to express this 24 plus 12x minus 2x squared in the form. This is what we are doing B. Do you want to do? Okay, 24 plus 12x minus 2x squared in the form A, open the bracket, x plus q raised to the power 2 plus k. All right, so now we have all the values of A, Q, and K. It's actually 24 plus what again? 24 plus what? 24 plus 12x minus 2x squared. 24 plus 12x minus 2x squared. So 24 plus 12x minus 2x squared, we are required to express it in the form of A, open a bracket, x plus q, close the bracket, squared, plus k. So we have all those values. So that's basically going to be, that's equal to substituting. That gives us A is minus 2, open a bracket, x plus q, and q is minus 2, that will be x minus 3, all squared, plus k, and k is 42. So that's that. All right, and if you compare it with what we had earlier, is the same thing we got earlier, minus 2, open a bracket, x minus 3, all squared, plus 42. That's what we got when we use the other method. Where did we do that? So that's what we did here. Let me zoom in very well so that I can reveal it better. That's what we got here. When we used completing of square method, that's what we got. See it here. Minus 2, open a bracket, x minus 3 all squared plus 42. That's the same thing. So whichever method, you will get the same answer. All right. So it's basically expanding the right hand side and equating it with the left hand side and compare the terms. Compare x squared, first of all x squared, compare the coefficients of x squared, compare coefficient of x, and compare the constants, and with that you can find all the other terms. I will recommend that you try using this method, this alternative method, in solving this question where we got this. We we got this for this question. 3x squared minus 9x plus 50. Use that method. By the way, with what we have, we can easily get the coordinate of the vertex for this question. Coordinate of vertex will simply be, therefore coordinate of vertex, coordinate of vertex, which is we can give us the turning point. Could be minimum or maximum. Coordinate of vertex, which of course is x comma y. X will be 3 comma 42, which means the maximum value of the function is 42, where x is equal to 3. In other words, y is 42 when x is 3. Remember, you pick the y, and then you, for this, k is the y, and then x minus 3 equal to 0 will help us to find the value of x at the turning point. In other words, if we wanted to find the turning point, we would have done x minus 3 equal to 0, which gives us x equal to 3. All right.
Please don't forget to like, subscribe, and comment. Thank you so much.
Welcome to Like Learning School, your premier online education platform. At Like Learning School, we are dedicated to helping students and learners unlock their full potential, providing them with the foundation, support, and guidance they need for academic excellence. Our platform caters to two main target audiences. Firstly, we work with school children of all ages, offering academic follow-up and accountability partnerships. Our seasoned tutors provide personalized attention to ensure students stay on track and reach their goals. Secondly, we support students and learners who are preparing for internal, external, entrance, or professional examinations. We offer comprehensive and well-structured support to help them achieve outstanding performance in their exams. Our robust virtual courses are designed to keep students engaged and motivated. With interactive videos showcasing our teaching sessions, students actively participate in the learning process, making education enjoyable and effective. But that's not all. We believe in personalized education. Our students have access to personalized tutorial sessions, whether online, physical, or hybrid, tailored to their unique learning needs. Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234 808 509 5144 to learn more and get started today.